Hi grade 7s, welcome back to another one of our video lessons. So today we're going to continue on page 92, which is compare and order decimal fractions. Alright, so remember we started off with normal common fractions and we want to see which one was bigger or smaller, and in order for us to do that we had to get the same denominator and then compare the fractions. Well, here we're going to look at the numbers, we're going to compare the digits to each other and we'll see which one is bigger or smaller. Okay, so the way we're going to do that is, let's start with the example on page 92. So it says compare the following two decimal fractions by replacing the star with the correct relationship sign, less than, greater than, or equals. Number one. So number one we have 15, 7142. And then the other number is 15, 7098. Okay, guys, these are our two numbers. We need to tell which one is bigger. Okay, so first part that you look at is the whole numbers. Okay, based on those, we can tell which one is bigger or not. If they are the same, which is here, then we have to look at each digit. Okay, so the first digit is a 7, next digit is a 7. Great, it's the same. Next digit is a 1, this digit is a 0. Okay, do you see that this number is already bigger because it has more value, so to speak, in each placeholder? Well, not even in each placeholder, but as we go from left to right. Okay, so already here we have a 1, there we have a 0. So straight away I can say, well, this number is bigger. The 15.7 part is the same. What do we have left here? 142. What do we have left there? 98. Okay, so this one is bigger. We put the greater than sign. Right, let's look at number 2. We have 13.46 and we have 13.4600. Okay, guys, so sometimes we give you two numbers to compare that don't have the same number of digits, okay? So if that's confusing you, what you can do is you can add zeros, okay? There's no problem with adding zeros here. So now I have 4 digits there, 4 digits there. Now we can compare. Okay, 13 is the same. First digit 4, 4, same. 6, 6, the same. 2 zeros, 2 zeros. Are these numbers identical? Yes, they are. So we put an equal sign there. Right, then number 3, we have 5.1523 and 5.1520. 5.1520. Is that right? 151, no? Sorry. 5.152. Okay, and 5.1523. Okay, so same thing. Well, here we have 4 digits after the comma. Here we have 3. We can put a 0 to make things easier for us. Okay, let's compare. 5, 5, same. 1, 1, the same. 5, 5, the same. 2, 2, the same. Here's a 3, there's a 0. This one is bigger. Okay, what you can do is you can cover the same parts. There we have a 3 left over. Here we have a 0 left over. Obviously, the 3 is bigger. That means that number is bigger than that number. Okay. Right, and number 4, we have 3.1204 and 3.2. Okay, well, guys, we could add the zeros, or we could straight away look at the numbers, right? 3 is the same. Next digit, here's a 1. There's a 2. Okay, straight away, this is already bigger than that because the next digit is greater than this digit. Okay, so that's greater than that, or less than. Okay. Guys, so that's how we're going to determine whether the decimal fractions are greater than, less than, or equal to. Okay. Right, the next worked examples looks at arranging the numbers in ascending order. So arrange the following decimal fractions in ascending order. Ascending, we're going up the flight of stairs, so we're going up, starting at the lowest, going to the highest. Okay, so I'm going to write these numbers out, and then we're going to arrange them. Okay, we have 3.31. 3.301. 0.301. 3.4. 33.013. Okay. And 3.41. Okay, guys, I know there's a bit of a glare there. So all I did is I just wrote out the numbers. They are in your textbook. We're on page 92 in the second worked example. Okay. Right, so we want to go from the lowest to highest. Okay, ascending order. So let's look at the first digit. Okay, we want to find the lowest one. Here we got 3 holes, 3 holes. Here we got 0 holes, 3, 33, and 3. Okay, so from this, I can already see that this is the smallest number that we have, which is 0.301. So it's 0.301. Okay, I've done that one. Next one. Well, let's look at the next digit. Okay, so, right, we've done that one. The next one starts with 3, 3, 3, 33. This will be the last number that we have, and there's a 3 there. Okay, cool. So let's look at the next digit here. So we have 31. Here we have 30. Okay, this one is less than that. Here we have 40. We can write a 0. So we got 31, 30, 30, 40. Okay, here this is 33. That's too big. And here we have 41. Okay, so this one and then this one. Okay, then we have between these two to determine which one is smaller. Which one of these is the smallest? Well, 3 is the same. 1, this is a 0. This one is smaller. So it's 3.301. Then we've done that. Then it's this one, 3.31. Okay, so remember we are ascending. We're going higher. Okay. So we started with a 0. Here's a 3.301. 3.1. So that 0 replaced by that 1. We've done that. Okay, we have 3.4, 3.41, and 33. So it will be first this one, 3.4, then 3.41, and then 33.013. Okay, guys, now that's arranged in ascending order. Okay, I suggest when you go through these, mark the ones that you've done off so that you don't do the same number again, so you know which ones to pick. Okay. Right, guys, so that is that example. Okay, the next following example on the next page says now complete these number sequences. Okay, so we just need to follow the pattern and complete the number sequence. So I'll show you how to do these. So they start with 4.7, 4.8, 4.9. Okay. Then they say complete these number sequences up to 5.5. So what we can see, we're going in increments of 1. Okay, so the next one will be, this will become a 10, which will add 1 more. So this will be 5.0. Next one, 5.1. Then 5.2. Then 5.3. Then 5.4 and 5.5. Okay. Number 2. 2.34, 2.36. Okay, so now the increment is a little bit different. So 2.34, then we have 2.36, 2.38, then we have 2.4. They want us to go up to 2.5. Okay. So remember, here we're adding increments of 2. So 34, 36, 38, 4, which is really 40. What's the next one? We're going to add another increment of 2 here. So it's 2.42. Next one, 2.42. 2.44. Next one, 2.46, 2.48, and the last one is 2.50. Okay, doesn't matter if you can write 2.5 or 2.50, it's the same thing. Right, number 3 looks at going in different increments, but now we're going down, we're not going up, so we are subtracting the increments. Okay, so we start from 3.4, then we have 3.1, then we have 2.8, 2.5. Okay, what are the increments that we're going? Well, we had 3.4, now we have 3.1. We went from 4 to a 1, so we subtracted a 0.3. Again, we subtract a 0.3, we get to 2.8. Subtract a 0.3, we get to 2.5. Guys, if you can't do this in like this in your head, do it on a piece of paper. So we know we're subtracting 0.3. So 2.8 minus 0.3 equals 8 minus 3 is 5. 2 minus 0 is 2. So it's 2.5. There it is. Okay. Next one will be 2.2. Next one will be 1.8. Next one, 1.5. Next one, 1.2. Next one, 0.9. Next one, 0.6. Next one, 0.3. And finally, 0. Because 0.3 minus 0.3 is 0. All right, guys. Oh, actually, wait. They only wanted to go to 1. So where do we stop? 1.3 and they get 1. Let's see. I made a mistake somewhere. 2.2 minus 0.3 is 1.9. Okay, then this is 1.6. This is 1.3. And this is 1. Okay, that's what they wanted. All right, guys, so we've done the 3 worked examples. What I want you to do is exercise 7.3. And then I'm going to do equivalent forms. And you guys are going to do 7.4 as well. Okay. Right, equivalent forms are very easy. We're converting from a decimal fraction to a common fraction and vice versa. Okay, so I'll run through the few worked examples. Remember from the previous lesson, we can remember decimal fractions are in powers of 10. And then we had a fraction and we broke it down into 1 over 10, something over 100, something over 1,000, and so on. All right, so now we're going to learn how to convert from one to another. So the worked example gives us 5 over 10. Okay, remember the fractions, the decimal system works in powers of 10. So we want to convert our fractions to denominators of powers of 10. So 10, 100, 1,000, 10,000, whatever. Here we already have a 10. So this is 5 tens. No whole unit, so it's 0, 5. Remember, this is tens, we have 5 of them. Right, easy. Next one, we have 34 over 1,000. Okay, equals no whole part, so it's a 0, comma. Right, now we are looking at thousands. Okay, do we have any tens? No. Okay, do we have any hundreds? Yes, we got 3. Do we have any thousands? We have 4. Okay, if you guys are getting confused with this, what we can do is we can show that this is actually 30 over 1,000 plus 4 over 1,000. Okay, all I've done is I've broken 30 and 4 apart. Okay, and if we add them together, they have the same denominator, they will give us this. But now I can also say, well, this, I cancel a 0 there. This becomes 3 over 100, 4 over 1,000. Now let's convert from here into our decimal fraction. Well, do we have any tens? No. So we have 0, 0, because there's no tens. How many hundreds do we have? 3. How many thousands? 4. Okay, and that's where we get 0, 034. Okay. Right, let's continue. Then the next one, we have 23 over 25. 23 over 25, which equals 2. Okay, remember the trick is to turn this into a power of 10. So how do we turn a 25 into 100? We times by 4. So we times by 4 here, times by 4 there. 25 times 4 gives us a denominator of 100, which is what we want. 23 times 4 gives us 72. 4 times 2, no, more, sorry. 4 times 2 is 80, 4 times 3, this is 92. Okay. Right, so now how do we convert that? Well, we got no tens, we got 92 hundredths, okay? But remember, the 92, the 9 is tens. Because remember, we can break this up as 90 over 100, which will cancel to that, will be 9 tenths, and 2 hundredths. Sorry, 2 hundredths equals 0,92. Okay. Right, guys, that's the worked example. So I want you to look at exercise 7.4 and 7.3 for homework. Thanks, guys. I'll see you next time. Hope you enjoyed the lesson.